Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 83 in our incredible new tutorial series where you are unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at SunFounder. SunFounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Kepler kit for Raspberry Pi Pico W. Now, hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to teach you is a logical extension of the work we've been doing in the last 3 or 4 lessons. Now, what have we been doing? We've been learning how to offload some of the work that we're doing down in our main program and offload that to run in the background. And specifically what I did was I showed you how you could set up timers that would interrupt your program, run off and run a special little segment of code, a special little function that you developed, and then go back and return execution of your code. And there's several advantages to doing things in the background using timers. One is you clean up your main program where you're not doing a lot of checking this, and doing timing functions. Your main program becomes cleaner. And the second advantage is a lot of the things that you might do with functions like time.sleep are blocking, meaning that while you're waiting, it locks your program up and you can't be reading a sensor if you're sitting there with a time.sleep. So by using timers, those are non-blocking so that if you're waiting for something, you're not locking up your main program loop. We showed that timers were very powerful. We showed that we could even do a complete binary counter with multiple LEDs, all without doing anything in our main program, just properly setting up those timers. Well, now the timers were based on doing things that needed to happen periodically, doing things that needed to happen every so many seconds or every so many milliseconds. Well, what we're going to do today is we're going to extend that same logical framework, but now instead of interrupting the program at periodic intervals defined by a timer, what we are going to do is we are going to set up a hardware interrupt where we interrupt based on something that happens on one of the pins of the Raspberry Pi Pico W. So let's say that you have something where you're sitting there and waiting on input from the user. When you're sitting and waiting on input, let's say from a button push, a very classic example of something that works very well and much better with an interrupt would be a push button. If you're sitting there in the main program waiting to hear from the push button, you could be blocking execution of other things in your code. Also, if you're doing all of that associated with a push button where read the button, what's the state of the button, what's the state of the button last time, blah, 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 your code, which maybe is trying to do something completely different, starts getting really, really complicated because of all of that management that you're doing on the push button. So what I'm going to show you today is how we can set up a hardware interrupt. We can connect that interrupt to a specific pin that has a push button connected to it, and that looking and reading the push button happens in the background instead of in the main program. Does that make sense? I hope it does. So let's jump over here, and I guess I should start by showing you my hardware setup. So let's go ahead and just take a quick look at the hardware. Let me get out of your way. Let me also have a sip of coffee, and let's take a look at the push button. The push button has one leg connected to the power rail, and the power rail comes over here. I am establishing that power rail. I am establishing that power rail over here by connecting to physical pin 36. So this is physical pin 36 is creating the power rail. Then I have physical pin 38 that is creating the ground rail. So I have power rail, I have ground rail from the 3.3 volts here and from the ground here. Then the left leg of the push button is connected to the 3.3 volts, and the right leg of the push button is connected to GPIO pin, is connected to GPIO pin 20. Okay, let me get further out of your way so you can see that. So this is GPIO pin 20 is connected to the other leg of the push button. Then I've got the long leg of the LED connected to GPIO pin 16, the one down here in the corner. Then the short leg goes through a 220 ohm resistor to ground. Okay, so we have a LED connected to GPIO pin 16, and we have the button connected to GPIO 20. Now, before we jump into this, we probably need to go back and we probably need to review how to turn on a pull-down resistor using Micropython, and how we're going to configure this button, because for the rest of this stuff to make sense, we've got to kind of make sure that we remember how the buttons work. So let's jump over here. Let me move this keyboard out of the way for right now. And so what do we have? We have a push button like this, okay? And so right now, the push button is in the open position. And then what did we say? We said that we had one leg of the push button connected to the voltage. Okay, so we'll just say V plus up here. The other leg, we are going to turn on an internal pull down resistor. So what does a pull down resistor do? It connects that other leg down to ground. It connects the other leg down to ground through a resistor that is internal to the board. And then what the system is actually reading is the voltage right here. So that pin 20 is actually going to be reading here at the top of the pull down resistor. And so what does that mean? Let's just review. Let's say that we are in the open position. Okay, if we are in the open position like this, what does this see? This does not see voltage up here, it sees ground, and there is no current, and so there is no voltage drop across this resistor. And so what does this see? This sees ground. This sees 0 volts, which is a logic 0. Okay, now let's say we push the button down. We push the button down. This is now connected. What does this see? This sees V plus, and so it sees 3.3 volts, which is a logic 1, if that makes sense. And so using a pull-down resistor, what does that mean? If the button is in the up position, you're going to read 0, and when you press the button down, you're going to read a 1. So a 1 means the switch is closed, the switch is activated. When you have your finger off the button, that means that you are reading 0 volts. You are in the off or in the 0 state. So hopefully that makes sense. That is how the pull-down resistor works. So now with that, we've sort of seen how we've hooked up the circuit, and we have seen how, reminded ourselves how the pull-down resistor works. Let's switch on over here to our code view, and let's see if we can start programming. And what are we going to want to do? We are going to want to connect this pin 20. We're going to want to connect this pin 20. We're going to want to attach an interrupt to that pin. So I will show you how to do that and then show you how interrupts work. So let's jump up here and let's see if I can just make sure that we are connected. Very good. Get a sip of the old Go juice and let's jump in and get busy. Now, what we'll play around a little bit with, toggling the LED with the button, but mainly we're just going to print to the serial monitor to show if we are properly toggling using the button. And then maybe we'll go ahead and turn that LED on before this lesson is over. Okay, well, we've got a couple of GPIO pins, so we're going to need to say from machine import pin, like that. I think our goal is not to use time.sleep, so I'm not going to import time this time, but we're going to have a butt pin, and that's going to be connected to pin 20, and then we have a red pin, that's that red LED, and we said that was connected to GPIO pin 16. And now, as I am pressing this button, it might be nice for us to kind of keep track of how many times it had been pressed. So I'm just going to set up a variable called press, and it is going to be equal to 0. And then also, I think that is probably about all that I am going to need to do there. So now down here, I need to set those pins up. So I'm going to say my watch button, right? Because what am I going to be doing with this pin? I'm going to be watching the button. And so my watch button is going to be equal to the pin, and that is going to be which pin? The butt pin. And then that is going to be a pin.in. And then what did I say I wanted attached to that? I wanted a pin.pull down. Okay, so what have I done? I've made pin 20 the butt pin, I've made it an input pin, and I have attached the pull down resistor to it. So now we should have this configured like I showed you on the old sketchpad a little bit earlier. Now let's go ahead and set up our red LED, and that is going to be pin. Which pin is that? That was red pin. And then what are we going to do to that? We are going to make that a pin.out. Pin.out. Okay, so now I've got my input pin and my output pin set up. Now, what do I want to do? I want to attach a interrupt to that pin 20, that GPIO pin 20. I want to attach an interrupt to that. Okay, how are we going to do that? Here is where the real action happens. We're going to say the watch button, which I've already set up. Let me put a blank space in there. Okay, this watch button, which we have already set up, watch button. Okay, what am I going to do? I'm going to dot interrupt request. So I'm going to set up this interrupt. I'm going to attach this interrupt where? Okay, I am going to first of all, well, it knows where because it's watch button, so I'm attaching an interrupt to watch button. But now I have to say what triggers it. Does it trigger it if you go from a 0 to 1? Or does it trigger it if you go from a 1 to a 0? So I have to say what the trigger is. The trigger is going to be equal to that pin.irq, that interrupt underscore. Now, what am I going to do? I think I want to trigger it on a rising, and that is where I'm sitting at 0, I'm not pressing the button, right? I'm sitting at 0, I'm not pressing the button. And then when the button presses and I go to 1, that is where I want to trigger. So that would be a trigger rising like that, okay? Now what I have to do is, okay, I triggered. What do I want to do once I've triggered? Once I see that rising edge on that pin 20, I have to tell it a handler. Okay, what I want to do, what is my handler? Well, I need to create a function here, and so I'm just going to call it the interrupt switch. Okay, so I'm going to have a function called interrupt switch, int switch, like that. You can call yours whatever you want. I'm going to call mine int switch. Now, if I'm going to call int switch when it sees pin 20 go from 0 to 1, I better what? I better define int switch. So up here, I'm going to say define int switch, like that. And then you've just got to put a variable here. I'll just say pin, just put something in there, okay? I'll put that. Now I have my function. Now what do I want to have happen when I press that button and I go from a logic state 0 to a logic state 1. Well, one thing is I want to count the number of times I press the button, and so I'm going to make press global. Now, why didn't I just make press a local variable? Because I want press to start at 0. And if I initialize press inside of this function, every time I press the button, it would come up and it would initialize itself again. So I just think making press 0 and making press global, that is very good. Now, if we get to this point, what does that mean? That means the button was pressed. And so if the button is pressed, pin 20 goes from 0 to 1. That is a rising. That triggers it, and then where does it go? It goes up here to int switch. And then what are we going to do in int switch? I better put a space there. Doesn't count as an error if you find it before you run it. Okay, so now what am I going to do? That means the button was pressed, so I'm just going to say press is equal to press plus 1, like that. Okay, and then I'm just going to print that I was triggered so that the user can see, or as we're debugging, we can see that it was pressed. So I'll say triggered, indicating that it was pressed, like that. Okay. And then the number of times it's been pressed so far. I think that's pretty useful. And then what I could do here is I could toggle the LED, but let's not do that just yet. Let's just look and see how this thing works. Okay, so I think what I'm going to do, really, could it be that easy? Could it really be that easy? Well, let's give it a try. So I'm going to run it. And so far, no errors. Now, when I press this button down, I'm going to get a rising signal on pin 20, and then that should trigger, and it should go up to this function. And then what it should do is it should increment press, and then it should print triggered press. So let's see it. Let's run the program. What is this? Oh, okay. I'm sorry. Yeah, we got a little rest of the program to work here. What it did was it ran and stopped because I didn't have a while loop. Now, also, since I have an LED, I want to be able to exit cleanly out of the program. And by cleanly, I mean clean up and turn off the LED. So I'm going to put in what we've learned earlier, the try and accept. So what do I want to try? Just a while true. What do I want to do in my main program? Pass. I don't want to do anything in the main program. I'm setting up interrupts, and all the action and all the work is done in the background using the hardware interrupts. So I do a try. If you have a try you want to accept, I want to accept out on keyboard interrupt, like that. And then what do I want to do when I exit out? I just want to do red LED. And did I set that up? Okay. Yeah, I set up a red LED. I'm not using it yet, but the red LED is set up. So what I'm going to do, a red LED dot off, like that. Okay, and that should turn the LED off. And that's just getting everything nice and clean to run. So let's just try and run this. So I'm going to say run. It's running. And now what is the keyboard interrupt? Control C. So I'm going to press Control C, and you can see the program cleanly exited. So it sort of did that. Now we don't feel too excited right now because the real action is happening up here in the interrupt, and we never actually press the button. Okay, so now what we're going to do is we're going to run it again, and now when my finger goes down, what I hope I see is a triggered 1. So I'm going to press it. I see a triggered 1, and I let my finger off, and everything was good. So what is just really, really cool, I have a non-blocking hardware interrupt that is running in the background, and now whatever I want to do down here, I can do without blocking and without complicating my code, because all of the interrupt stuff is handled up here at the top at the sort of setup part of the program. Now, because we're good engineers, we're going to really test our code. So I pressed it once and it worked. Now I pressed it again, it worked. 3 times, okay, 4 times, 5 times, 6 times, 7. Ooh, look at that. What just happened? When I pressed it the 7th time, it went 7, 8, 9. So I got 3 triggers based on 1 button push. Okay, 3 triggers based on 1 button push. Let me try this again. So I'm going to do 1. Ooh, look at that. I got 3 triggers on 1 button push. Okay, 4, that's good. 5, that's good. Now you see I'm pressing very deliberately. 6, that's good. 7, that's good. Oops, no, I got 7, 8, 9. Okay, 10. So what is happening? We are getting what is called switch bounce. And what is switch bounce? As you are coming down, you kind of make contact and then don't make contact, or you make contact. It's sort of like, imagine dropping something on the floor and it bounces a few times. You press that down, and in those milliseconds or microseconds that it's making contact, it bounces around a little bit. It bounces around as you go down, so it goes kind of like this, and when you let up, it bounces as it's going back up. And what that does is each one of those is generating, each one of those is generating a trigger. So now that sort of shows what our problem is going to be. So let me come back over here, and let's just go ahead and put the red LED dot toggle like that. Okay, so then we come over here and let's run it again. And so now let's keep all eyes here on this. And so if I come in, I'm going to press it very deliberately, and then it comes on. I let it off. I press it very deliberately and it goes off. Okay, I press it very deliberately, it comes on. So I have it again on the down press, which is the rising from a 0 to a 1. And so you see, if I am very careful, I can kind of make this work. Okay, but then if I just come in like this and I'm not so careful in the way that I'm pressing the button, or sometimes if I kind of move it around a little bit, it's very, very easy for me to get this where it doesn't work. And as engineers, what we've got to do is not just do it a few times and say, okay, it's working. We have to really, really, really make this thing. Like, imagine that this was the button to launch a thermonuclear weapon. You wouldn't want it to make a mistake, right? You would want to be very deliberate that when you press it, you want it to go, and when you don't press it, nothing happens. So you've got to be very, very deliberate about debouncing these switches, okay? Now, that is going to be your homework in a minute, to debounce the switch, but let me show you some other things that you can do here. Now, what I did was I made the thing trigger on the rising edge, which is as my finger goes down, it goes from 0 to logic 1, and then that is a rising logic level. And so what if I say make it falling like that? What if I change it to falling? Okay, in that case, when I press the button, nothing happens, and when I let it go, it toggles. Okay, now again, I'm pressing very deliberately and it's kind of working, but if I just am kind of careless, you see, if I'm careless, I'm getting extra triggers and it doesn't work. And so that is the problem. Now let me show you what you can also do. You can put an OR in here. Like if I want to trigger on either a rising edge or a falling edge, I can put the OR in there. That's that vertical bar, and I can say OR pin.irq dot. Let's see, I was doing a falling. What was I doing there? I was doing a falling. And what is a falling? I go from 0 to 1, and then when I let my finger up, it goes from 1 to 0. Is that what that was doing? Let me make sure. Okay, this is saying a falling would be when I let my finger off. Okay, a falling is when I let my finger off. Yeah, okay, so we did falling and we did rising both. And what I can do is I can put an OR in here. I can put an OR in here, that vertical bar. It's usually on the right part of your keyboard above the Enter key, and you've got to do a shift to get there to it. But I could do an IRQ falling or rising. Okay, now in this case, let's run it and see what happens. Okay, now watch down here on the printout down here. Okay, so as I go down, I am triggered the first time. As I let up, I'm triggered the second time. Down, I'm triggered the first time. Up, I'm triggered the second time. Now, this isn't very useful as a toggle switch because now it's kind of made it not toggle. But what you can see is I can trigger on the rising edge. I can trigger on the falling edge, or I can trigger on both the rising and the falling edge like I've just shown you. So that's kind of a pretty neat little thing there. Also, let me see if I can, let's just kind of look at the other thing that I want to do is let's play around with a little bit of sort of looking at our timing. Okay, let's look at our timing a little bit. We're not going to do any time.sleeps, but if I just say P time for press time, P time, what is the press time? And I could set that equal to 0. And then what I could do in here is when I enter this, I could measure P time. And how would I measure T time? I could do it, I think I've got an import time, even though I said I wasn't going to use it. Import time. I can time this thing by going out and grabbing the time. P time is equal to time dot ticks underscore milliseconds. And so that'll look at the number of milliseconds since the program started. Okay. And so when I get into this interrupt, I'm going to grab the time and put it into P time. And then when I get down here to the bottom of the loop, I'm going to say P time old is going to be equal to P time old is going to be equal to P time, like that. That looks pretty good. And then if I'm going to have this P time here, I'm going to need to make it global as well. P time. Why does P time need to be global? Because the first time I use it, the first time I get here, it has to have a value. So I need that. No, really, it's P time old because I'm going to read P time soon enough. So it doesn't need to be like that. It'll read it. What do I need? P time old. And then why? Because the first time through the loop, P time old doesn't have a value, if I'm thinking about this right. So I will make that. Okay, so the first time through, I don't think I need to make any of those. For this is simple enough. It can all be handled down here. No, it can't. No, it can't. Okay, so it's the P time old indeed. And you'll see here in a minute. You'll see here in a minute why. I'm kind of programming on the fly, so be patient. P time old is going to be equal to 0. All right, now, how long between calling these functions? And so what I can do is I can print triggered, that it was triggered, how many times it has been pressed. And then what I can do is I can print P time, the present time, minus P time old. And this P time old is why I need to have the global variable, because the first time through the loop, there is no value on P time old. It is defined at the bottom of the loop. So I've got to kind of seed a value into it of 0, and then P time minus P time old will have meaning the first time through the loop. So let's run this, okay? And so we've rebooted, and so now I'm going to press the button, and it says line 12 local. What is that? Okay, P time has a value. P time old. Make sure that I did this. I didn't put it up here as global. I thought I'd done that. Had to make that global. So now let's try it. Run it. Okay. So now when I go down, now it doesn't like, still doesn't like variable referenced before assignment in line 11. Press P. I got some typos going on here. All right, let's try to make it run this time. Okay, so now down, it still doesn't like it in line 12. Okay, press is defined here. Press is defined up there. P time has a value because it was set here, and P time old is set here, P time old. And we've just got to make sure that all of these are the same. And make sure that they are exactly the same. I see the problem. I said time old instead of P time old. That was why it wasn't recognizing it. Okay, so now we're going to come in, and then it is triggered, and then it is triggered when I let up. So this second trigger means that the button was held down 1,785 milliseconds, or 1.7 seconds. Now what I can also do is, let's see if I do a very short. The first trigger is going to be a large number because it's sitting timing right now while it's waiting for the next event. So the first number should be very long and the second number should be very short because I'm going to give it a short. Okay, so yeah, so you see it was about 30 seconds that I was talking there. I was talking for about 30 seconds, and then it was 63 milliseconds. So that was a very fast push. Let me see if I can do about a second push. 1001, and I let it up. Yeah, and so you see that's 1257. So you see you can kind of play around with this with timers. Now, why am I showing you how you can set and measure these things inside of here? Because now what I want you to do is I want you to debounce your switch. Okay, I want you to debounce your switch. Now, I know that you guys, first of all, I got to be very, very specific and say you cannot do a time.sleep to debounce your switch. Why? Because if you put delays up in this interrupt function, you're completely defeating the purpose of the interrupt function. And so what your homework assignment is to debounce this switch, to debounce the switch where it works perfectly no matter how you press the button, and you never get those spurious signals. And I should talk more, because since I'm giving you this as a homework assignment, we really need to kind of understand how it works. And so let's see if I can get this this set up here again, and let's kind of look at exactly what I mean by debouncing. So I'm going to come over here and let's see if we can get that to come on. There it is. Okay. Now what you think is, when I press the button down that GPIO pin 20 goes from 0 to 1, and then when I let it off, it goes from 1 to 0. So in an ideal world, that would be I press the button and I go to a 1, and when I let the button off, I go back to a 0, like that. And if that's the way things worked in the real world, it would be very, very easy. But in fact, what happens is when I press the button, it jiggles a little bit. It's got a little vibration. It just like takes a little few milliseconds to get that jitter out of there. So if you looked on the scope, what you're actually going to see is something that looks like this. A few bounces. It might be one bounce, it might be 5 bounces, or it might be no bounces. But you're going to get bounces. And what's going to happen during those bounces? The light's going to come on and off and on and off. The LED is, or the toggle state's going to come on and off, on and off, and on and off. And you can actually end up in a very strange situation there. So what you have to do is you have to debounce that out of there. Now, complicating things even further is that when you're here and you let the button off, a lot of times you get the worst bouncing when you're released, okay? And when you're released, you could get another set of these little pulses, okay, like this. Okay, you could get another set. Now, what's going to happen? Let's say that I had something like this. And let's say I got a clean on the down, but when I released, it wasn't clean. Okay, what's going to happen? When I go up, the LED is going to turn on. When I come over here and I come down, it stays on, but then I get this bounce, and that bounce turns it off, and then it comes down, and then it bounces again, and it's going to turn it back on. And so you could get 2 bounces that leave you in the right state, but if you got 3 bounces, you're going to end up in the wrong state, okay? So you have got to somehow, what is that? Okay, hold on just a second. I got something crazy going on here. Okay, there. So you've got to somehow come over. You got to debounce these, and you've got to debounce these. Now, I'll tell you another thing that can happen. Another thing that can happen, let's make another one. Let's make another one. Another thing that can happen is you can come up and you can get a bounce when you press the button down. And as you're holding the button down, if your finger wiggles a little bit, you can get some bouncing here in the middle of the press down. And then you come over, and then when you let the button off, you can get some bouncing. Okay, so what is your homework assignment? Your homework assignment is to debounce this switch, where no matter what you do, every time you press it, you get exactly one toggle, okay? And you can't just go in and press it a couple of times and say that mine works. And so let me give you an example of how you really need to test this thing out, because there's different types of button pushes. There's the guy that pushes the button quickly. There's the guy that pushes the button slowly. He holds the button down and then release. There's the guy that gets 2 quick button pushes. There's the guy that has a long time between his button pushes. So you need to show me like 50 successful switches without an error. So let's start by doing long button pushes. So I'm going to press and I toggle and I get a trigger and I hold it down and release it. That was 1 long, 2 long, 3 long, 4 long, 5 long, 6 long, 7 long, 8 long, 9 long, 10 long. So you see, for the long button push, it worked perfectly every time. Now let me do quick pushes. And so that is 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I got 10 solid long pushes without an error, 10 solid short pushes without an error. Now let me do 2 quick button pushes. And so I'm going to, 2 button pushes that are close together. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me do the long, clumsy one where I'm kind of moving my finger around while it's down. So I press down, that's 31, and I move my finger around. 32, move my finger around. 33, move my finger around. 34, move my finger around. 35, 36, 37, 38, 39, 40. Now, I'll have to tell you, I used to give this assignment in high school, and there were very few students that could debounce a switch where I couldn't get it to give a wrong thing. So when we're trying to do well and we wrote the program, we tend to try to not break it, so we test it easily. But I want to see who can come up with the most robust debounce switch. So let me go and let me do the short ones again. Let's just get up to show you that I'm going to do 50 tests. So that's 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. Okay, so you see I did quick presses, I did long presses, I did presses close together, I did presses where I held long and jiggled the switch around to see if I could generate a little jitter in that thing. And in all cases, I showed you 50 that were working perfectly. Okay, guys, this is I think it's pretty straightforward. Let's see, that debounce program that I just did was 33 lines of code. So it's not a lot of code, but you've really got to think. What you've really got to think through is you've got to think through this picture I showed you and all the different cases that you have to think through to make this thing work right. Now, it's a thinking problem. It's not a writing a whole lot of lines of code type of problem. So that is what your homework assignment is. Okay, guys, I hope that you are enjoying taking this class as much as I am making it. I've had a lot of fun with the timers, and now you've learned interrupts. You know how to do the interrupt. Your homework assignment is to go away and debounce mouse that where it works perfectly, because as we move forward, we are going to be using this debounce switch. As we move forward, we're going to be using this debounce switch, so we need to have a good one. As always, I want to thank you guys who are standing with me on Patreon. YouTube has not really been showing me any love, and so you guys that are supporting me on Patreon, you are the ones that keep this great content coming. You can also help me by leaving a comment down below. It also helps when you subscribe to the channel if you'll ring that bell so you'll get notifications when future lesson comes. And most importantly, share this video with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.